Hey guys, how's everyone doing? Welcome back to our daily pre-cal videos. Today we're going to go over something new and we're going to talk about tangent functions. Now to begin with tangent functions, we're going to do the same thing as we did with sine and cosine. We're going to define the properties of it. Let's see, go there. Boom, that comes up. Good. So with tangent functions, okay, we need to talk about, I guess, the initial thing for these, the properties. We need to talk about what tangent x is equal to. So if you can remember back, tangent x is actually equal to sine x over cosine x. So whenever we can think back to those properties when we graph sine and cosine, remember it was a fluctuation of up and down, so it went on forever. Now the only difference is tangent x is equal to sine over cosine. So anytime that cosine x was 0, which was at pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2, and forever on, okay? For every time it's equal to one of those zeros, remember your function actually doesn't exist because you cannot divide by 0, okay? So that is why, if as you can see here, we have these lines. So we go on to infinity as we approach negative pi over 2, but we never actually touch it because we can't divide by 0. So that's why this looks like, and you see these red lines, there are vertical asymptotes, and you just see it repeat over and over again. Okay, so you'll kind of see what that means in a bit, but we can define certain characteristics. So when we talk about some of these, so first thing we're going to talk about is our domain. Well, the domain, remember, is all possible x values. So for this one, we would say x is everything, right, except these. So x cannot equal pi over 2 plus n pi. Okay? And n can be any number that's any whole number, right? It can be positive 1, 2, 3, 4, 5, 6, negative 1, 2, 3, 4, 5, 6. Okay? It can be any of those numbers. And we'll say that right here, where n is a whole number. Okay, now for range, let's talk about range. So for range, remember that's your y values, that's up and down motion. So for this one, we can go down to negative infinity and up to positive infinity. So our range is actually going to be negative infinity to infinity, or we can just say all real numbers. Okay, x-intercepts. Well, every time we have an x-intercept is when it crosses the x-axis, which is here, 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 or sorry, here, here. So every time it's some form of pi or something along those lines, okay. Sorry, this is focusing in and out. There we go. Okay, so anytime it's one of those values, we know it works. Or sorry, we know we have their x-intercept. So what we say for that one is n pi, okay, where we say the same kind of thing, where n is a whole number, and that's just saying n can be 0, 1, 2, negative 1, negative 2, and so forth. Okay, that's how we can get that function. Y-intercept. Well, y-intercept is where we cross the y-axis. We only cross the y-axis at one point in time, which is here. So y is equal to 0. We can actually say x is equal to 0 right about there. Okay, continuity. Well, for this one, remember continuity is it does it not work. Well, this one has what we call, if I could spell, sorry, infinite discontinuity. Infinite discontinuity, okay, and that's at x is equal to pi over 2 plus n pi, where n is a whole number. Okay, then we talk about symmetry. Well, does this have any symmetry? Well, once again, this type of symmetry, if we take this and we try to fold it along the y-axis, okay, like this, we can tell this is not going to match up with this, so that doesn't work. If we fold along the x-axis, as such, this will not match up with this. So it doesn't have x-axis or y-axis symmetry. But if we were to take this function and rotate 180 degrees, okay, it now resembles the exact same thing it did as it was initially. So what we say for symmetry is origin symmetry, which is considered an odd function. Extrema, maxes and mins. There are no maxes because we go to infinity and negative infinity, so not applicable, okay? And we talk about end behavior, okay? So for end behavior, we want to say the limit of tangent x as x approaches negative infinity. Okay, so what happens as x approaches to negative infinity? Well, it keeps going on, it keeps going on below, right? So we can say this actually doesn't exist. But as we go to positive infinity, the same thing. We keep fluctuating between going up and down, up and down. So we can say the limit as tangent x approaches negative infinity and the limit of tangent x as x goes towards positive infinity does not exist. And that is simply because it keeps fluctuating up and down. Now the last one we want to talk about, okay, are asymptotes. So for asymptotes, remember those are the lines that we cannot cross, okay? And they actually happen to be the same as our continuity, okay? Because remember, it can equal those points, so our asymptotes are at those lines. So we can say for that one, x is equal to pi over 2 plus n pi, where n is a whole number, okay? And that's it. Those are the properties of tangent functions, okay? So they're pretty simple along those lines. Just make sure we always can refer back to this table, this everything we did. Take a screenshot if you need to, okay? But that's it, guys. I hope everything's going well. I hope you have a good Easter break. Peace.